was to see if the average human could submerge a bucket underwater and still be able to breathe for a short amount of time using the air pocket in the bucket while underwater.
We based our myth off of this scene in Pirates of the Caribbean. In the scene, Jack and Will are able to submerge the boat using only human strength. We believe that this would be impossible in real life because you would need a lot more force to hold the boat down. We wanted to put this theory to the test. Let's see what the professor has to say.
Really analyze what the forces are. We know something's pulling it down, the force of gravity, right? Something's doing that, obviously the Earth is doing that. And if it isn't actually moving, somebody must be holding it up. Well, we call that the force of buoyancy. Okay? They have to be equal and opposite. What if the force of buoyancy were stronger? What would happen? It would go up. And that doesn't happen in water, does it? Water doesn't spontaneously jump and spout out. Neither does it spontaneously splash down to the bottom of the pool. So in fact, these are equal. Very simple. The force of buoyancy on that chunk of water is equal to the force of gravity that that water has. Well, how do we figure that out? It's quite simple, actually. It's the mass of the water times the acceleration due to gravity, 9.8 meters per second.
Well, if that's true, if it's really this water that provides this, when I do the swap, does this water know that I did it? No. It knows it's experiencing something the exact same shape. So it's pushing back as much as it ever used to, right? So this is the kicker. The force of buoyancy is equal to the mass of the water that has been removed times G.
So it turns out this water, the mass of water is pretty easy to calculate. The mass of water is simply equal to its density. So this is 1,000 kilograms per cubic meter, roughly. You guys may be used to a gram per cubic centimeter. I like kilograms, cubic meters, right? So 1,000 kilograms per cubic meter, right? Times the volume. Literally, how big is it?
So, if you put in something that's heavier than water, right? It's going to sink, because this water down here says, we're used to holding up water. Oh my God, you're not going to water. We get crushed. But if you put something in that's lighter than water, what happens?
So what you do is you fill the thing up with air, which is exactly what your myth is all about. Trap the air so it can't get out, right? You trap it in air.
And that is stinking heavy. Imagine filling up a boat and trying to lift it, right? The force it would take you to fill up a totally soaked, flooded boat is exactly the same force it takes for you to submerge an air-trapped bubble boat, right? And you watch that clip in that movie. They're not even pulling, right? They're just hanging on. Having a conversation. No way. This is monster. That thing would shoot up.
Hi, we're here with a real pirate to see whether or not Captain Jack Sparrow was really able to pull a boat underwater and breathe. So, you're a real pirate?
Aye, my name is Scurvy Joel, captain of the Damnation of the Devil, the baddest boat ever to sail these Great Lakes.
So you're from Minnesota?
Aye, Wyndham being my home port.
Tell us about your favorite pirate story.
Well, there I was on the Mississippi River, Wisconsin Royal Navy nipping at my heels. Apparently, they don't like it when you pop a feeler on the Commodore's wife. Anyways, I was taking on water, and I only had my sword and a pistol with one shot. The boat was going under, the lifeboat was dangling. So I slashed out with my sword and knocked the lifeboat into the water. Unfortunately, I had to leave my ship, and I landed in the cool depths of the Mississippi. And then, all of a sudden, the lifeboat popped up. And I remember an old pirate tale, two scallywags able to tip the boat under and breathe under the air pocket. So I pulled the boat under and walked to safety, escaping those damn cheeseheads. Made it to the Isle of Tortuga. Little rum never hurt anyone in the Harkeys.
Do you think this was actually working, or was it just a coincidence?
I just told you it worked. I'd use this approach anytime. That would save me from Davy Jones' locker.
Some people believe, including the extremely accredited Professor Andy Runkus of Hamlin University, believes that this is impossible.
What does that landlubber know about sailing the high lakes and seas of Minnesota? He's probably never even seen the ocean or the lakes. Remember, a pirate always speaks the truth. Professor Andy Runkus don't believe me. It'd be the plague, and then the Kraken for him.
As you can see, Professor Runquist was correct. It was a struggle to keep the bucket underwater for more than a few seconds without us and the bucket floating up.
In our small-scale experiment, we saw firsthand why it was so difficult to keep the bucket fully underwater. As you can see by the way we set up this experiment, there's a lot of air trapped inside the cup by the way the ping pong ball is still floating.
We took the mass of the cup filled with water and converted that to newtons to see if the force was equal. When we measured the force it would take to submerge the cup underwater, we saw that both the filled cup and the submerged cup had equal forces, confirming Professor Runquist's lecture.
When all is said and done, we know there is truth behind this myth. When submerging a bucket, or a cup, or even a boat, there is going to be an air pocket that would allow a person to breathe for a short amount of time.
The downside is that it is physically impossible for the average human to hold a boat underwater with their own brute strength, although it is possible to do so if there was enough force holding the boat down.
We were physically able to hold the bucket underwater, but we couldn't keep it down because we would float to the top. If we had some sort of anchor planting our feet to the ground, any of us would have been able to hold the bucket completely underwater.